Unit 7, pages 121 to 124, Finding the area between two curves, an application of integration. So usually when we find the integral, what we've been doing is finding the area between the curve and the x-axis. Now we're going to talk about how to find the area between two curves. So the first thing we want to do is graph the function f of x equals negative 1/2 x squared minus 2x plus 4, and find the value of definite integral from negative 5 to 0 of f of x dx. Using one color, shade the region for which this value represents the area. Okay, so what I'm going to do is I'm actually going to go off camera and graph this and shade it in so that you see what the final product looks like. All right, so everything in green represents f of x and the area between negative 5 and 0 of f of x dx. So in order to identify what that green space is, we want to first find the antiderivative. So we're going to go through and actually find the antiderivative from negative 5 to 0 of negative 1/2 x squared minus 2x plus 4 dx. Going through this process, we get add 1 to the exponent, divide by our new exponent. So we have negative 1/2 x cubed over 3 minus 2x squared over 2 plus 4x, and put that from negative 5 to 0. So then we have negative 1 over 6 x cubed minus x squared plus 4x from negative 5 to 0. And now using Fatak, right, when we plug in 0, we get 0 minus, when we plug in 5, we get negative 1 6, 5 cubed minus 5 squared plus 4 times 5, so negative 5s. So we get 24.167 is that area in green. Okay, so now we want to graph the function g of x equals 1/2 x plus 4 on the same grid above and find the value of negative 5 to 0 g of x dx. Using a different color, we want to shade the region for which this value represents the area. So again, I'm going to do this off camera and bring you back once I finish. Okay, so now in blue we have the graph of g of x, and shaded in blue we have the definite integral from negative 5 to 0 of g of x dx. So to find that actual integral, let's do the math. So we have negative 5 to 0 g of x dx is the same thing as going negative 5 to 0 of 1/2 x plus 4 dx. So that's 1/2 x squared over 2 plus 4x. We're going from negative 5 to 0 to 1/4 x squared plus 4x from negative 5 to 0. Plug in 0, I get 0, minus 1/4 times negative 5 squared, that's 4 times negative 5, which is equal to 13.7. So what do you suppose you would do to find the area of the region that is located between the graphs of f of x and g of x? So if we go back and look here, that specifically is asking for this space in red, the area between f of x and g of x. So to find that area, right, using our Algebra 1 skills, we know that that requires us to subtract. right? So subtracting will give us the area between f of x and g of x. So we'll take 24.167, subtract 13.75, and we'll get 10.41. So what we did there was we took the definite integral from -5 to 0 of f of x dx and subtracted from it the definite integral from -5 to 0 of g of x dx. Okay, so now we want to find the value of the definite integral below if f of x is equal to -1/2 x squared minus 2x plus 4 and g of x is equal to 1/2 x plus 4. We want to show our work for this. So what we'll get is the definite integral from -5 to 0 of -1/2 x squared minus 2x plus 4 minus 1/2 x plus 4 dx. We can combine these to be the definite integral from -5 to 0 of -1/2 x squared minus 5/2 x dx. So when we integrate this, we get -1/2 x cubed over 3 minus 5/2 x squared over 2 from -5 to 0, which gives us -1 over 6 x cubed minus 5 over 4 squared from -5 to 0. When we plug in 0, we get 0, and subtract from that -1/6 -1/6 times -5 cubed minus 5/4 times -5 squared. Plug that into a calculator and we get 10.417. So if we look back at the bottom of our previous page, we'll notice that those are the same values. So what we get when we did -5 to 0 f of x dx minus -5 to 0 of g of x dx is the same as -5 to 0 of f of x minus g of x dx, because they both equal 10.417. So this brings about the general way that we find the area between two curves. Okay, so the area between f of x and g of x will be equal to the definite integral from a to b of f of x minus g of x dx. But there are some conditions. So this only works where x equals a and x equals b are the x coordinates of the points of intersection for f and g. Okay, so a and b have to be the points of intersection. We go back to the previous page, you'll notice that at x equals -5 and at x equals 0, the two graphs intersect each other. Also, where f of x is greater than g of x, which means that the function above on the interval is f of x, and the function below on the interval is g of x. And you'll notice when we do more problems that they can switch positions. So if you look here, the function that was on top on our interval was f of x, and the function that was on the bottom of our interval was g of x on this interval in particular. But if we were to go outside of that interval, let's say from 0 to 1, the function on the top would have been g of x and the function on the bottom would have been f of x. So you really have to pay attention to the position of these functions when you write this integral. So now we want to find the area of the shaded region R that is bounded by y equals sine pi x and y equals x cubed minus 4x. So the first thing we want to do is first identify which equation is which in the graph. So sine is an oscillating function. So I'm going to say that this is the y equals sine pi x equation. I'll rewrite it in red so that you can see it just a little bit better. And then this function down here is the y equals x cubed minus 4x equation. So in this case, sine pi x is greater than x cubed minus 4x on this interval. All right, so we have which function is greater. Now we need the points of intersection. So our points of intersection are 0, 0, and 2, 0 in this case. So my A will be 0 and my B will be 2 because it's the x values of my points of intersection. Okay, so now I have everything that I need to write the definite integral for the area of R. So the area of R equal to the definite integral from 0 to 2 of sine pi x minus x cubed minus 4x dx. So now I'm going to integrate this. So one thing I'm just going to do is I'm just going to split this because the sine pi x is one function and then the x cubed minus 4x is another. So I'm just going to split this integral. That's 0 to 2 sine pi x minus dx minus x cubed minus 4x dx from 0 to 2. So the definite integral from 0 to 2 of sine pi x, we really have to pay attention to what's happening here. We have an inner function, which is pi x. The derivative of pi x is pi. So we need to have pi somewhere in this integrand. So I'm just going to put pi here. And to keep this balanced, I need to also multiply by the reciprocal. So now I have the license to integrate sine pi x. So this is going to be equal to 1 over pi times negative cosine pi x minus, and then here I just add 1 to the exponent, divide by my new exponent. So I have x to the 4th over 4 minus 4x squared over 2, and I'm going from 0 to 2. So this is equal to negative 1 over pi cosine pi x minus 1/4 x to the 4th minus 2x squared from 0 to 2. All right, so when I plug in all the values, I'll get negative 1 over pi cosine 2 pi minus, I'm going to distribute this minus sign, minus 1/4, 2 to the 4th, plus 2 times 2 to the 8 to the 2nd, minus negative 1 over pi cosine 0 pi minus 1/4, 0 to the 4th, plus 2 times 0 squared. And with that, I get negative 1 over pi minus 4 plus 8 plus 1 over pi plus 0 minus 0 is equal to 4. So the area between those two curves is equal to 4. Okay. So now for the next problem. We have the graph f of x is equal to x cubed over 4 minus x squared over 2 minus x over 2 plus 3 cosine x. So because this has a cosine in it, I know that the graph of this function is this oscillating one down here. So this is f of x. And the line L, which is tangent to f of x at the point x equals, at the point 0, 3. So this point 0, 3, and the line L is tangent to that point. So first thing we want to do is find the area of the region R. So in order to find the area of the region R, we need to know the limits of our integration. So we needed to know when this function f of x touches the x-axis. So when does f of x equal 0? F of x equals 0 when, and I did this using a calculator, when x is equal to negative 1.373122. Okay, so instead of rewriting this number every single time, I'm just going to let the letter A equal negative 1.373122. That way, when I write my definite integral, I don't have to repeat that number over and over and over again. So the area of R equal to definite integral from a to 0 of f of x, because this is just the space between f of x and the x-axis, which is just a regular definite integral dx. And when I put that into a calculator, I get 2.903. So now we want to find the equation of the line L if it's tangent to the graph f of x at 0, 3. So if I want the equation of a tangent line, there are two things that I need. I need the point of tangency and I need the slope of tangency. Point of tangency I get by plugging in the x variable, the x value into the equation to get the y, or it'll give it to me. So this point of tangency is 0. Slope of tangency is when I need the derivative, and I'll plug in 0. So I need to find f prime of x. So to find the derivative, subtract 1 from the exponent, multiply, right? Bring down the exponent, subtract 1. So we have 3 over 4x squared minus 2 over 3x minus 1/2 plus 3 times negative sine x. So when I plug in 0, I get 0, 0, 0. So 0 minus 0 minus 1/2 minus 3 times sine of 0, which is 0. So sine of 0 equals negative 1/2. My slope of tangency is negative 1/2. So my equation is y minus 3 equals negative 1/2 x minus 0. So y equals negative 1/2 x 3. That is the equation for L. Right. So now, at what ordered pair other than 0, 3 does the graph of line L intersect the graph of f of x? So using my calculator, I just wanted to look at when do these two graphs intersect other than 0, 3. It'll be a little bit larger than 3 in the x-axis and between 1 and 2 in the y. So line L intersects f of x at the point 3.3898677, 1.3050662. The reason why I put so many decimals after is because these numbers are going to be used later on in the problem. So I want as many decimals as I possibly can have so that when I plug them in later on in the problem, it doesn't round the number too soon. It gives me a more accurate answer. So now we want to find the area of region S. So if we look at our graph, region S is the space between line L and f of x. So what we need to know in order to write this definite integral is which function is on the top. In this case, line L is greater than f of x. So L will be my first function. Next thing we need to know is the limits of integration. So we know we'll start at 0 because that's our first intersection point. And then we'll end at the second intersection point, which we found to be 3.389, so on and so forth. So that I don't have to rewrite this every time, I'm going to let B equals 3.3898677. And I do this not just for my paper, but also in my calculator. You can store these numbers into your calculator so you don't have to retype them every single time. So the area of S equal to the definite interval from 0 to b, negative 1/2 x plus 3 minus f of x dx. And when I plug that into a calculator, I get 6.982. Okay. So now we run into a problem where the two functions can be interchangeable when it comes to which one is the higher function and which one is the lower function. So here we have the regions R and S, which are formed by the graph f of x equals 1/4 plus sine pi x, and g of x equals 4 minus 4 to the negative x. So we have to first identify which function is which, right? So in order to do that, what I did was I graphed both of them in my calculator. I made this y1 and this y2, and I looked, right? So when I looked, I found that this shorter line here is g of x, and this hump of a line here is f of x. First thing we want to do, identify the points of intersection for f of x and g of x. So f of x and g of x intersect at 2 points. So using my calculator, I found those 2 points of intersection. 0. 0.1782180.5, comma 0.781091174, and the and the point 1, comma 0.25. So what I'm going to do is I'm going to let this be A. So our first point of intersection occurs when x equals A. Our second point of intersection occurs when x equals 1. So to find the area of region R, the area of R is equal to definite integral from 0 to A of, in this case, for region R, our above function is g of x. So we have g of x minus our lower function, which is f of x, dx. So I'll plug that into the calculator, and I get 0.065. This is a lot of calculator problem. Okay, so I want you to take that information and now find the area of the region S. Okay, so for this final question, we want to find the area of the unshaded region bounded by the graphs f of x, g of x, and the x-axis. Okay, so here it's a little trickier. We want to know what this unshaded region is. So everything under here, including that little tail end past x equals 1. So in order to find that, we need to know the limits of integration, right? So we can go from 0 to A to 1, and 1 to this point over here. So we need to know, when does f of x equal 0? So in my calculator, I looked for what that was, and it was x equals 1.0804306. So I let that be the letter B. So we have the interval from 0 to A, from A to 1, and from 1 to B. So our area equal to the integral from 0 to A. We'll fill this in a second. The integral from A to 1, and the integral from 1 to B. So since we want the area below the curve here, we need to figure out which function are we looking at each time. So the first function we're looking at is our red function, which was f of x. So we want from 0 to A, f of x dx. The second function, once we get past A, is going to be our blue function, which is g of x. So from A to 1, we're looking at g of x dx. And then our last function, this little sliver in the corner, is going to be our red function. We're going to go from 1 to B. So that's f of x dx. And when we plug all of that into a calculator, we get 0.486. Okay, so finding the area between two curves is really important for the next things that we do, which is going to be finding the volume. So there aren't a lot of homework problems relative to this particular skill only. So there's only one homework problem that is relative to this particular skill only, and then we apply this skill to the next video where we look for volume of a solid created by these areas.